Hello everyone, this is Yiwen Zhang. I will talk about my research project using Poisson regression for the estimation of unknown cases of COVID-19. These are the contents that will be included in this presentation. So now let me introduce this research project. COVID-19 is a respiratory infectious disease caused by a new coronavirus. The first cases was found in Wuhan, China on December 2019. It was thought spread through the air and by the close personal contact or by the touching contaminated objects or surface. People with COVID-19 have a wide range of symptoms ranging from mild symptoms such as fever and cold to severe illnesses including the difficulty breathing. According to the report released by California Health and Human Services Agency, until May 8th, California have had 73,164 confirmed cases of COVID-19 and resulted in 332 deaths. And the number of COVID-related deaths is increased by 3.3%. However, can we think that the number of actual total cases is equal to that of known cases? No. As we can see in the following figure, the number of known cases per day sometimes increases and sometimes decreases in the last 2 months in California. For example, as shown in the table, from April 3rd to 4th, this number of known cases per day decreased from 1,412 to 898. And then, from April 4th to 5th, this number increased from 1,500 to 1,512. And then, from April 4th to 5th, this number increased to 1,512. Since the COVID-19 was spread in California in March, the number of new known cases per day should increase continuously and then remain constant. Hence, there might have been some unreported cases. So I decided to use Poisson distribution and regression model to estimate the number of unreported cases. The picture on the right side are the function and diagram of the Poisson distribution. Poisson distribution is a discrete probability distribution which is used to calculate the probability of a given number of events occurring in a fixed interval of time or space. It was introduced and published by Artemio Diniz Poisson in 1837. And the Poisson regression model is used to count the data that are fed by a number of known predictor variables. It was based on the Poisson distribution. So now let me talk about the data I collected for this research. Of course, I collected data of the number of known cases per day from March to May in California. However, since my assumption was that the number of known cases per day is increased continuously, so I chose the period from March 20 to March 29 for the calculation, and then put all the data in the figure. So now I will tell my methodology. Since I was not so familiar with regression model, so I just initiated Joe's who also use the Poisson regression model to predict the number of unreported cases of COVID-19. First, I used the dn to represent the number of new cases on the end state, and I used di to represent the number of known cases, and ni for the number of unknown cases. Hence, there exists an equation dn equal to di plus then ni. After that, I modeled the Poisson regression model for dn series as an exponential growing Poisson process. And then I estimated dn and then the in-streak growth rate of the exponential growth, which is denoted by r, based on the log likelihood from the Poisson periods, which is denoted by L. I also use a profile likelihood estimation framework with a cutoff of the threshold determined by a chi-square criteria, PR equal to 0.95, DF equal to 1, to estimate the 95% confidence interval of the unreported cases. These functions can help us to obtain the basic reproduction number. It was hard to find correct information about transmission chain of COVID-19, so I adopted the SI information from the severely acute respiratory syndrome and Middle East respiratory syndrome, which share the similar pathogen as COVID-19. Through the calculation, I made this table and figure. As we can see, there were many unknown cases. In other words, the situation of COVID-19 infection was much more serious than that most people think. For example, as we can see in the table, on March 29, the number of known cases is 1,169, and the number of unknown cases is 1,301. And so, the total number of cases is 2,417, which the 95% interval is 2,395 to 2,517. Hence, the number of actual cases is twice the number of known ones. This shows that the actual cumulative number of cases per day is much more than that most people are aware of. So now let's turn to the discussion. First, let's think about. Let me tell you my thoughts about why there exist unreported cases. First, it may be caused by humans' resistance. Some people maybe who have infected by COVID-19 do not go to the hospital for treatment because there was no any symptoms showed on their bodies. According to the research, the human's body existed a mammalian cells which possess a variety of innate barriers retrovirally infection. Hence, it is very possible that people may be infected by COVID-19 without showing any symptoms. Another reason may be caused by the governance ignorance. An investigation by the New York Times has revealed that the experts and administration officials tried to warn President Trump of the serious nature of the coronavirus pandemic. However, Trump issued concrete guidelines for the public after 6 weeks. This shows that Trump did not notice the warning of COVID-19, and therefore it is possible that the government may not test all the people, and so the number of known cases is smaller than that of actual ones. Of course, although there also exist some errors in my data, which is the erratic new case per day count, because it may be caused by my assumption the number of actual cases per day is increased over time. However, there are many reasons which can affect the number of the infection, as I mentioned before. Hence, the number of actual cases may be increased, may fluctuate irregularly. Besides, I initiate John's ways, but his condition is different from mine. The period he chose is that there was no new cases of COVID-19 in the period. But for my situation, the number of new cases in the California is still increased all the time. Hence, this may lead to the range of errors would be larger. Finally, it's now turn to the conclusion. To sum up, since the number of new known cases per day very regularly showed on the upside of shown on the right one's the first figure on the right side. So I just think that there may exist many unreported cases which may be not reported by hospitals because of they do not have any symptoms or governance ignorance. Since I used the general Poisson regression model to estimate the number of unreported cases, and by collecting the data of the number of known cases in California from March to May. And finally, I find that the number of unreported cases was even much more than the unreported cases, which means, in other words, the situation of the COVID-19 infection is much more serious. For further research, I will change focus to estimate the actual number of cases by analyzing the mortality rate of the COVID-19 and through another model. After that, I can use this rate and non-death cases of COVID-19 to determine the total number of cases and find the number of unreported cases. That's all.